When daylight slowly surrendered into darkness during a solar eclipse in ancient times, some civilizations believed the spectacle was the result of an enormous creature devouring the sun. In the centuries that followed, solar eclipses continued to be seen as harbingers of disaster or death. Eclipses were thought to be harmful to pregnant women. Some people were suspicious that eclipses had the ability to make food toxic. But as science evolved, mankind debunked these superstitions and, in turn, demystified solar eclipses. Eventually, scientists like Sir Arthur Eddington, whose observations of deflected starlight during a 1919 solar eclipse confirmed Albert Einstein's theory of relativity, considered the rare celestial events as prime opportunities to learn more about the solar system and beyond. Nearly a century later, on August 21, a new generation of scientists are preparing to conduct another slate of experiments during the first total solar eclipse over the U.S. since 1979, and the first to span the continental U.S. since 1918. NASA officials are planning to conduct research projects across the path of totality, where the sun will be completely covered, that include atmospheric balloons, aircraft, satellites, the International Space Station and the city of Carbondale, where the eclipse will reach its greatest point of duration. Carbondale will see the sun's face completely blocked for 2 minutes and 43 seconds, beginning at 1:20 p.m., during which time NASA intends to obtain high-resolution imagery and various other measurements. Bob Baer, a Southern Illinois University physics professor, will be taking telescopic images of the eclipse in Carbondale as part of a NASA initiative to collect photos from nearly 70 sites in the path of totality. The experiment aims to map electrons within the sun's atmosphere, known as the corona, and could answer the question of why the sun's surface, which is several thousand degrees, is so much cooler than its atmosphere, which has been gauged in the millions of degrees. What we're hoping to do is take images and stitch them together to make a long movie of the corona, Baer said. Anyone in the path of totality will see it for about 2.5 minutes, but the strength is in the network. Over 90 minutes we should see the evolution in the corona and see the corona changing. The ultimate goal is we want to be able to predict when solar flares happen, and, right now, we can't do that with good accuracy. Astronomers can view the sun's corona with a device known as a coronagraph, but the innermost reaches of the sun's atmosphere, called the photosphere, remain elusive outside of solar eclipses, according to Chris McCall, director of Triton College's Kernan Earth and Space Center in River Grove. The mechanism that blocks out the sun in a coronagraph also obstructs views of the sun's atmosphere closer to its surface, McCall said. During an eclipse, astronomers get an exceptional chance to study the photosphere just up to 100 miles from the sun's surface, she said. NASA will also be taking high-definition images and measurements of visible and infrared light from 2 WB-57 jet planes flying over the path of totality in Missouri, Illinois and Tennessee. The flights are expected to net the clearest pictures of the sun's corona to date, because, at 50,000 feet above ground, the sky will be 20-30 times darker than as seen from the ground and there will be much less atmospheric turbulence. In addition to shedding more light on the dynamics of the sun's atmosphere, the images could reveal whether a hypothesized family of asteroids between Mercury and the sun exists. Chicago's Alder Planetarium will be taking its own high-flying observations during the eclipse. The planetarium's Far Horizons team, a group of students, volunteers and Adler members, will travel to Perryville, Mo, to launch a pair of high-altitude balloons into the stratosphere to capture 360-degree video of the eclipse. Larry C. Upik, director of Adler Planetarium's Dome Observatory, hopes even the most modest observations could help scientists fine-tune a knowledge of the solar system. We very accurately timed the moon's passage, but each time there's an eclipse, we can time its orbit a little better, C. Upik said. You have to be in totality to see the precise moments of time the sunlight hits the edge of the moon where it's cratered or there's a valley. People in the path of the total eclipse can expect twilight-like darkness. The wind usually picks up, and temperatures drop. But weather forecasts could be a challenge for local meteorologists who will have to somehow account for reduced or no sunlight. The entire North American continent will see at least a partial eclipse, which is expected to result in temperature drops up to 20 degrees and an uptick in wind, according to NASA. I'm not really sure if we have a forecast model or if we'll have to make manual adjustments, said Mike Bardou, a National Weather Service meteorologist. The last total eclipse was 1979 in Hawaii, so I don't know if historical data can be modeled. It will be a learning experience in that regard. The sudden, albeit brief, transformation from day into night has elicited strange behavior in animals in the past. Birds have been known to return to their nests and insects to sing as if it were night. And when sunlight was completely blocked during one eclipse, scientists in Mexico observed orb spiders tearing down their webs. Though Chicago is expected to see only a partial eclipse, with 87% of the sun covered, it will be the closest the city has been to the path of totality since 1925. And the Lincoln Park Zoo is using the opportunity to closely monitor its animals in outdoor enclosures, including great apes and snow monkeys. They'll certainly react to the dark and temperature and react to environment, but to see whether they react to it in a meaningful way is difficult to tell, said Steve Ross, director at Lincoln Park Zoo's Fisher Center for the Study and Conservation of Apes. I think the primates are what we'll be interested in watching because they are cognitively advanced. But I think many birds will be interesting because they have trichromatic vision, so they are also relatively sensitive to light. For people in many places, the total solar eclipse could be a once-in-a-lifetime event. In any given place, a total eclipse happens only once every 100 years or so. Chicago won't see one until 2099. But Carbondale will see its second total solar eclipse in April 2024. If you stood still, you should see an eclipse about once every 150 years, so this is less than a 1% chance, Adler C. Upik said. These little lines cross the Earth over the period of hundreds of years. That's why people go around chasing it with planes that go above the clouds, cruises that you can find and road atlases. With an opportunity for repeat experiments, researchers surely will be returning to Illinois. Briscoe at ChicagoTribune.com, Twitter at _Tony Briscoe.